when we look at this growth, cartilage altogether has got to grow, all right? But the one cartilage that's going to really be helpful to the skeletal system is going to be the hyaline cartilage. Do you remember when looking at the hyaline, how I said it looked like little pretty flowers? Okay, had the little glassy appearance to it. Okay, so if we look at how we're going to see that offspring grow, well, interstitial means that within this area we can end up getting more matrix laid down and more of those blasts turning into a site. Okay, now if we need to grow in width, we can add to the periphery of that cartilage. Okay, so we can add to the periphery. This is a representation or showing my perichondrium, that connective tissue layer surrounding that entire piece of the cartilage. All right, this is the area of my cells that I need to get, okay, because this is going to be the part where I have my chondroblasts that can begin to lay down matrix to get stuff stuck and trapped to become my site. Now, in the case of the fibrocartilage and the elastic cartilage, all they do is simply maintain. Once they're at full growth for the fibrocartilage and the elastic, all they do is maintain. In some areas of the body where we find hyaline cartilage as an adult, all it's doing is maintenance. But in the area of the body that is going to allow for the growth, this will eventually become bone. It will actually be taken over by bone cells, which is kind of cool. Okay, like invades and just takes over.
So just like growth plates?
The areas that we know as a growth plate. But we can't just keep it at that one level, because bone is going to have to harden and grow throughout the entire lifespan. And so it's going to allow for that to take place. So the area of the growth plate is where we're going to see that hyaline be very present, but then as it extends out and out and out, we're seeing the bone invade it and give us the structure that we have as the hardened bone.
My cousin broke his growth plate.
Yes. And you have to make...
What
you need to make, like, because my son broke his wrist with the growth plate also, you want to make sure that whoever sets it knows exactly what they're doing. So you would most likely want like a pediatric orthopedist, because you don't want anything to mess up, because it can end up off kilter for the growth. Yeah, you can mess up and have one arm longer than the other. Yeah. Now for bone histology, our bone cell. Oh, the matrix. Love it. Okay? I just love what bone can do. We've talked about the idea of concrete, where collagen is the rebar and the calcium phosphate, the hydroxyapatite, is the cement. So we've kind of talked about that. The organic portions of this hydroxyapatite, of this bone, okay, collagen because collagen is a nice little protein makeup fiber that we've got. Our proteoglycans, they're also present in bone. Not as much as what you might see in cartilage because they're so active in but they're there. Our inorganic portion is the hydroxyapatite, the calcium phosphate, that minerals part. If minerals get removed, like I was showing, if we had to pull calcium and phosphate out of the bone can get bendable. If collagen gets removed, it can get brittle. Either situation, not good, okay? Don't think I want either one of them to really be present. The matrix of bone, by dry weight, about 1/3 of it is the organic portion, 2/3 the inorganic. So about 2/3 of your bone is the hydroxyapatite, the minerals. That organic matter, the collagen and the proteoglycans, okay, these are mixtures of proteins and sugars and other molecules. Other minerals are also found in bone. So about 85% being that calcium and the phosphate, 10% we'll see is roughly calcium carbonate, and then some other minerals that are needed. We need them in very trace amounts within the body, so only small amounts of it's going to get stored, okay? A lot of those minerals that we see, okay, we're going to use them, all right? We say that bone is a composite because it has all of these different products that are found in it. We've got organic, we've got inorganic, we've got the part of the rebar, the concrete. We call it a composite. Ever heard of this one? Rickets? Okay. Used to be like late 1800s, early 1900s, very prevalent. And then, of course, you know, our pirates and stuff like that on the high seas, because they didn't have access to citrus fruits. And one of the things that it does, we get a deficiency in the calcium salts. As a child, okay, as a child, when they have rickets, their bones are soft, legs usually end up bowing out under the weight of the body, okay? And the children, and you know, it might even be so severe. Now, you know, they can put them in braces and give them the supplements and stuff like that. But, you know, before we had all that type of help, their bones would be soft and they wouldn't form correctly. As an adult, we can have a situation that's genetic. It's called osteogenesis imperfecta, or more commonly, brittle bone disease. People's bones break very easily. And, you know, we can have the situation where it's a genetic problem. There can also be situations where it's nutritional, okay? Different countries throughout the world, famines, other disasters that may have taken place, may have affected their foodstuffs, and it's now affecting other parts of the body. Now, when we talk about that bone cell, we have our blasts, our cysts, and our clasts. There's another one that I'm going to introduce you to. It's a stem cell. Okay, but we'll get to that and just, you know, later in the chapter. But we find, just like we've been looking at with cartilage, we have to have our blast. Blasts are the immature cell. They can lay down their matrix over the collagen fibers, giving us the hardened matrix. The site, the osteocyte, is once again stuck in a lacuna. The process that's going to happen between the blast and becoming a site is going to be termed ossification. Ossification is simply hardening of the bones.
Isn't there a disease where things get ossified or something?
Yes, that's usually when calcium levels are too high in the blood, and so rather than depositing that calcium into the bone, it deposits it into soft tissues, such as the liver, the kidneys, the arteries, other parts of the body. There's a major difference now. When we talked about the cartilage and we're laying down and we get another site, is there any connection from site to site in the cartilage? Do I see a connection from site to site for the bone cells? Yes. This is a major difference. This is one of the reasons that we say bone is dynamic. It is not static. Bone is constantly breaking down, building up, because these cells have a connection to each other. Take a break. Be back at 12:30.